All right, part 2 of section 12.3. We're going to hopefully finish here with the inflammatory response and then with fever. So, with the inflammatory response, all right, in general, it's going to be a response to any sort of injury or trauma. And generally, it's going to be considered as a good thing. But as this slide starts off with, that inflammation can actually be chronic. And when inflammation is constant, it really doesn't serve a purpose. It doesn't serve the purpose that it was designed for, and so it can contribute to chronic diseases, such as cardiovascular disease, inflammatory bowel disease, joint disease. A lot of those, there's just a lot of diseases out there that if you were to figure out what is causing the inflammation and stop that inflammatory event, the disease would go away. So inflammation can be local and it can be systemic. With systemic inflammation, that would be a cardiovascular disease. That would be something that is spread throughout the entire body, whereas localized inflammation would be if you sprained your ankle and your ankle swelled, if you got cut with a knife while fixing dinner and your finger, once the bleeding stopped, it got red, it got inflamed, it hurt. That is local. All right. So there's research out there that says aging is a consequence of increasing inflammation in different parts of our bodies, and so that causes us then to have the appearance of aging. Now, factors that are going to cause the inflammation, for it to begin, again, would be trauma, and that trauma can be from infection, it can be from tissue injury, and it can also be from necrosis, right? Just a lack of blood flow to an area that causes tissue death. And this can be physical or chemical agents that are causing this. But what inflammation is it actually is a specific sequence of immune reactions. So, the major functions of the inflammatory process, and again, this is going to be a purposeful response, is to mobilize and attract immune components to the site of an injury. And by doing that, it sets into motion mechanisms for tissue repair. And it should be localized if the immune components are going to the site of actual injury. And then the purpose there would be to clear away harmful substances. In addition, bringing more immune components to a particular site can help in the destruction process of microbes and actually stop further invasion. So, here you have table 3 looking at the inflammatory reaction, and it's not that big here, but the first step is going to be the injury, and that injury is going to release different chemical mediators. That's going to be immediate, and those chemical mediators, cytokines, are released by blood cells. They're released by the tissue cells that are being damaged themselves, and platelets that can also be damaged in that injury process, whatever that is going to be. The figure here has or shows a nail. And nails often get a bad rap when it comes to a person stepping on them or something. It can be a thorn on a rose bush. It can be a paper cut that can cause this injury. But you do run the risk, if you have any sort of wound or puncture, that bacteria can get into the wound. And then you move to step 2, where you have the vascular reactions. And the vascular reactions are going to be caused because of those chemical mediators and those cytokines. What happens generally is going to be vasodilation, where the blood vessel or capillary there in the area is going to expand, and a lot of times during that vasodilation process, the cells in the vascular wall, the endothelium, will start to loosen, and so material can get out of the blood much easier. Now, you also have the little purple guys there, or the big purple guys. The little purple guys are the bacteria, but you have neutrophils there. And remember, neutrophils are going to be right there ready for phagocytosis. And in the yellow there, you see seepage of plasma and migration of white blood cells out of the blood vessels. And again, that's because of that vasodilation. Now, that process of material moving out of the blood cells is going to cause the swelling. Right? The vasodilation itself causes very small amounts of swelling, but it brings more fluid, more blood movement to the area, and then plasma can leak out into the tissue. In step 3, you have edema. That's the swelling. And what edema is, it's actually an accumulation of fluid, but it's a fluid distribution process, or a fluid distribution issue. So the fluid is normal fluid that really should be within the blood, within the vasculature, but it's coming out and it's getting stuck in that area of injury. And so that fluid is going to take up space, and you're going to have the swelling because of that edema. All right, now the fluid is going to contain different plasma proteins, different cells, and so in section, or in stage 3 there, you see a lot more neutrophils. All right, the neutrophils are going to be drawn there because of those chemical mediators and the cytokines, and now they are there to engulf and phagocytize the bacteria that are there. Right? There's more bacteria there because over time they're going to replicate. And what you see with the yellow background there is pus forming. All right, pus is mainly neutrophils, as we learned from a few slides ago, and it's just going to continue. All right, then in stage 4 you have resolution. All right, hopefully resolution doesn't take too long to start in that process, or to start the process of resolution. All right, because those neutrophils have come in, they phagocytize the bacteria, and now the area is clear and it's ready to move forward in that healing process. And so you can have a scar formation, right? That's just the body trying to heal itself to cause a seal so no more bacteria can get in there into the wound area. All right, you have additional lymphocytes that are there. Those could be your B cells and your T cells, which we'll talk about in chapter 13. And you also see those big purple guys, right? Those are your macrophages. Those are going to be very instrumental in not only phagocytizing the bacteria, because the neutrophils will do that as well, but the macrophages can help to present some of the digested bacteria to those lymphocytes and help then stimulate the specific immune response, the third line of immune response, so that the next time you run into the same bacteria because you stepped on a nail or you're working in the garden again, you're not going to have such a response because you're going to have specific immunity already built up. And the problem here, where you are allowing bacteria to grow, the bacteria just simply don't grow as quickly or as high because you have specific immune cells that can come in and clear that very quickly. All right, here is a kind of a blown up picture of the process of diapedesis and kind of chemotaxis, sort of, with the white blood cells or the neutrophils. So chemotaxis is going to be the movement of these neutrophils due to a chemical stimulus. All right, they're going to be attracted to this chemical. And so the neutrophils are going to be in the vasculature. They're going to figure out a stimulus. So the stimulus is just right here, but it's going to be elsewhere as well. All right, kind of drawing those cells to that specific area. And the vasculature, the endothelium cells, will go through the process of margination, where they're going to have their margin between the cells increase. And diapedesis is the actual movement of the cells out of the vasculature into the tissue. So they're squeezing themselves through the breaks in the cells there, and that process is diapedesis. All right, fever, again, can be a good thing, usually is a good thing. It can also be a negative thing. So normal body temperature is about 98.6 degrees Fahrenheit or 37 degrees Celsius. You can have a low-grade fever of about 100 to 101 Fahrenheit. High fever is going to be 104 to 106. That middle area is kind of a danger zone of either it's as bad as it's going to get, or you got to be careful because it could get worse. The fever or the body temperature is going to be set by the hypothalamus, and if pyrogens are introduced into the body, that's going to cause the hypothalamus thermostat to reset. So pyro is fire, and pyrogens are going to be substances that cause the hypothalamus to increase the body temperature, to create a fire in the body. Exogenous pyrogens are going to come from the outside. All right, they're outside of the body. So these are going to be infectious agents. All right, they're going to be viruses, bacteria, protozoa, fungi, endotoxin, blood products, vaccines, and injectable solutions. All right, things that are going to cause the body to have a fever. Endogenous pyrogens are going to be material that's liberated by the monocytes, the neutrophils, the macrophages. All right, and that's going to be from within. Endo is within. And so those are going to be the chemicals that are stimulated by the white blood cells to say, hey, there's a problem here. Let's increase the temperature just a little bit to try to make the environment a little less hospitable. All right, and the benefits of fever, it can inhibit multiplication of temperature-sensitive microorganisms, all right, particularly cold viruses, a lot of viruses and fungal pathogens. It will also impede nutrition for the bacteria because the higher temperature reduces the availability of iron in the blood. Some bacteria need extra iron. And then it will also stimulate metabolism. And that is your own metabolism because your body is going to go into hyperdrive to try to fight off the infection. And so it stimulates the immune reactions to occur faster. So speeds up hematopoiesis, the generation of new red blood cells or new blood cells in general. The process of phagocytosis, and then also some specific immune reactions. And there's been a commercial on TV for I don't know how many years, maybe decades, maybe from when I was a child, where instead of taking medicine, the person is just going to feed the cold. All right, so I don't know if you've experienced this, but when you have a cold, you may not be interested in eating a full meal, but rather you kind of graze all day long, taking small snacks or small meals multiple times a day. And that's simply a response due to the fever and sometimes just your immune reaction if you're fighting a bacteria but you don't actually have a fever. All right, all of this is going on during that time.